Bismillahirrahmanirrahim. Today we're going to start lecture number 7, module number 2 for information system security. Last time we talked about this asymmetric and symmetric keys. Okay. Today we're going to talk about why using a key, why we need a key, and what is the purpose of key. So we will discuss in more detail about the key. We can create different encryption of one plain message just by changing the key. So it means that if we change the key, the ciphertext we get from the plain text will be changed as well, although the message will be same. If you make 10 copies of one message, okay, and you apply 10 different keys on the same message, the ciphertext will be different. Okay, so this is the beauty of the key, that the key changes the ciphertext. Using a key provides additional security. Means how we can provide additional security to the key. If the encryption algorithm should fall into the interceptor's hands, future message can still be kept secret because the interceptor will not know the key value. What does this mean? It means that sometimes we keep the algorithm secret and key as well, okay, but in case if the algorithm is exposed to anyone, if the equation is exposed to anyone like Caesar cipher C equal to P plus 3, okay, if this is exposed to any person or any the intruder or the hackers, okay, so but still we must know the we must know the key. The key should be secret as well. Okay, so this is one of the beauty of the key, that even if the algorithm is or the equation is or the function is hacked, but still the key will be secure. What can a cryptanalysis attempt to do? Okay, cryptanalysis means breaking your ciphertext. You can break a single message, like recognize patterns in a encrypted message to be able to break subsequent ones by applying the straightforward decryption algorithm. Okay, so pattern is very important thing in recognizing and to cryptanalysis a cipher. Okay, so when you just catch a pattern in any ciphertext, then you can easily decode it or decipher it. Infer some meaning without even breaking the encryption, okay, such as noticing an unusual frequency of communication or determining something by whether the communication was short or long. Okay, sometimes frequency plays a very important role. Like for example, you can see in our communication the frequency of letters I is very much like O is very much like high, or the frequency of V and W and X, these may be not that much higher. Okay, so if you analyze a single sentence, or if you analyze a word, okay, you can see the frequency of different words or letters. Deduce the key to break the subsequent message easily. For example, if you guess the key, if you deduce the key, so you can easily break the message. Then we have a find weakness in implementation or environment of use of encryption. Okay, what are the different weaknesses either in an algorithm or in the implementation or in the environment or in the key, or for example, if the fingerprint is encrypted, so sometimes you don't need to decrypt the fingerprint, but you can send just 0 or 1 to the enabler, and by this way you can easily open the door. So find general weakness in the encryption algorithm without necessarily having intercepted any message. Okay, what this sentence means, it says that we need to find some weaknesses, general weaknesses in algorithm without necessarily having intercepted a message. So it is not important that we intercept a message by some way, by tapping or something, but sometimes we can see the weaknesses in algorithm. By this way we can easily crack it. So there is more further detail about the cryptanalysis, what they can do and what they can't do. They say that cryptanalysis cannot be expected to try only the hard and long way. Okay, so it is not necessary that always we need a hard and long way. Sometimes it can be easier, sometimes it can be harder. Analysts can can use educated guess as well, combined with a careful analysis to generate or almost an important message. So it is not all the time necessary to apply a complex equation algorithm to deduce or to decrypt it, but sometimes by guessing or by intelligent guess you can deduce the text. The example is World War II, 1942. A for Midway Island between US and Japanese. This is one of the examples that they make an intelligent guess in 1942 in the World War II. Moreover, they say that estimates of breakability are based on current technology, not the future. Okay, so if there's something you want to breakable, so you need to find the current. What is the current technology? The current technology, if you can break it, so that will be awesome. Things that were infeasible in 1940 become possible in 1950s. Yeah, that's also one of the things that, for example, the cipher is very simple one. In that the time when it got invented, it was very hard to break it. But now for us, it is just like even the kids can break easily. Remember Moore's law. You know about the Moore's law. The Moore's law, they say that the speed of a processor doubles every 1.5 year. Okay, and this conjunction has been true for over 2 decades. Okay, now you can see before computer was very slow, the process speed was very low, but now if you can see, you cannot imagine even our mobile speed is so high, our cell phone speed is so higher than our expectations. Now there are some examples you can see over here on this slide, and they say that use the mathematical form below. That how you're gonna use the mathematical form below. Let's analyze what they have written and how it can be sorted. The letter A is represented by a 0. Okay, that's fine. So they start the letter with a 0, not 1. B as a 1, okay, and so on. And Z about 27, I think. Yeah. We can perform simple modular algorithm on letter using the corresponding code number. Okay, so the modular code or modular algorithm arithmetic means like you take the modulus. Modulus means, for example, you rotate. For example, after 26 or 27, you need to come back to the original position. Okay, just like, for example, if you say more 10, so it means more 10 means like you need to start from like 0 1 2 3 4 5 6 7 8 9 10, and then you come back to 0 1 2 3 4 5 6 7 8 9 10, and then come back. Okay, so that is just like a round and round. If you say modular 13, so it means like you need to go to 13, for example, 0 1 2 3 4 5 6 7 8 9 10 11 12 13, and then come back to 0 again, and then it rounds and rounds and round. Okay, similar is the case in the alphabet, from A to Z and then from Z to A back. Okay, so that becomes the modulus. Okay, now we see here that they have written that A plus 4 equal to E. That's true. Yeah, why? How? Because in the value of A is 0, as we have assumed that, as we have supposed that A is 0. So if we add 4 with the A, so it means that so if you see that the position of 4, what can be the position of 4? If you see the line number 2, it starts with a 0 1 2 3 4. So if you map the 4 with that one, so it becomes the E. Okay, now we see K minus 2. Okay, so K is, if you see the value of the K is about 10. Okay, so the value of K is 10. So 10 minus 2, it becomes 8. So the corresponding letter for this 8 is I. Okay. Similarly, if you see Y, so if you see Y on the second row, what is the value of Y on the second row? Where is now? So on the third row. So on the third row, you can see over here, Y is 24. Okay. So after 24 plus 3, it becomes like 24, 25, 26, 27. Okay, so but here I cannot see 27. Okay, it ends with the 25, because if you start with the total are 26 letters, now we start with the 0, it becomes 26. Okay, I was wrong, it is not 27 or 27, it is the letters are 26, but it is if you just start with the 0, it becomes 25 total. Okay, so 24 plus 3, it becomes 27. So now if you see 24, 25, we need to move back to the original position. 26, 27. So 27, the corresponding letter for 1 is B. Okay, so I hope this will be clear now, and if you need to practice, you can just assume some more equation like this one and then practice at your home. Okay, now there is another kind of some more algorithms which is known as substitution and transposition. These are very interesting, especially for mathematics students. Mathematics, those who are good in mathematics, they can like it and they can learn it easily. So substitution and transportation, not transportation, so that is substitution and transposition. So substitutions means like you substitute something, you replace one thing by another thing. Okay, you replace one employee by another employee. You replace one alphabet with another alphabet. Okay, transposition means like you just transpose it. You just make the rows into the columns or columns into the rows. So usually it deals with the arrays. Two simple forms of encryption. So they say that it's very simple. Yes, of course it's very simple, but you must know the ABC of mathematics. Substitution, in which one letter is exchanged for another letter, is very simple definition, and I think no need for explanation here. Transposition, in which the order of letters is rearranged. Okay, so order is important. So as I told you, the simple way, if you change the rows into columns and columns into the rows, or if you change the orders, if you make the first letter last letter second, okay, or just like a moving stream, okay, so that can be performed as well. So transposition, these are two basic form of encryption. The Caesar cipher. Caesar can see a substitution. Caesar cipher is one of the the basic and first invented cipher. Caesar was a king, I think, yeah, a popular king, I think Roman Empire. Okay, so Caesar cipher, they use what they develop. They develop a very interesting scheme. Okay, as you can see over here, they invented this on a wheel. Okay, on a wheel, and they divided the wheel into two what do you call it, circumferences. Okay, so in the first donut, in the first circumference, the space between two circumferences, you can see you have from A to Z. Okay, and in the second one, if you see, they have replaced, they have another one like can I find the A? Yes, I found the A. Here A is here. From the big one, the A is here, and the smaller one, A is here. So the big one, the big circle, or the donut circle, you can see over here A, B, C, it starts from A to Z. Okay, the whole circle is complete. Now if you see over here, the A starts from here, okay, in the smaller circle, and A, B, C up to Z. Okay, and you can make many rounds according to your needs, according to your complexity, so that your enemies or your attackers cannot know. Each letter is translated to the letter a fixed number of places after in the alphabet. Okay, Caesar used a shift of 3, so plain text letter PI was enciphered as ciphertext letter CI by the rule. So what is the rule? Rule is CI equal to E PI. P is the plain text, C is the ciphertext, and E is the encryption scheme. What is the encryption scheme? They told that PI plus 3. The 3 is the main form of encryption scheme, for example, and they took the mode of 26. Why 26? Because the total letters are 26. In general form, using the key as a key, K as a key. So you can see over here, you can replace the 3 with the K. So K can be any number, 1, 2, 3, 4, anyone. If it is 0, so it will be the same. Okay. So it means if it is 0, it means that there will be A and here will be A, so there is no difference over here. But you can move this circle, this round, okay, and you can move this one. So now A is with N. If you move a little bit here, so A will be with M. If you move a little bit A here, the A will be with the L. Okay, so these are movable circles over here. So these are the basic for the information security. This is very interesting. If you find this kind of Caesar cipher circular things, okay, it is usually made of metal. My teacher, he showed to me at class. Okay, maybe if I find, so I can show you in the class as well. Okay, for now, okay, thank you for listening this lecture, and pay concentration on it and practice more. If you practice, you will learn. Otherwise, you will forget it. and stay tuned with us for